Maybe you know. Science meets the questions you never thought to ask. In February 1974, two astronomers named Bruce Ballack and Robert Brown were hunched over a stack of printouts from the Green Bank Radio Telescope in West Virginia. They were chasing something faint at the heart of the Milky Way. What came back was a single, sharp, a radio source no one had cataloged. They called it Sagittarius A star. They didn't know it yet, but they had just photographed the gravitational monster that holds our entire galaxy together. And it had been waiting 26,000 years for the signal to reach them. For most of human history, we thought the center of the galaxy was just more stars, a thicker crowd. In the 1930s, an engineer named Carl Jansky pointed a clunky homemade radio antenna at the sky and noticed a steady hiss coming from the constellation Sagittarius. He didn't know what it was. He just called it star noise. For 40 years, that was it, a buzz from somewhere in the dust. Then in the 1960s, theorists started doing something uncomfortable. They started writing down equations that suggested galaxies should have something massive, really massive, sitting at their centers. Not a star, not a star cluster, something else. The math kept producing the same word, a word physicists used very carefully back then, singularity. But nobody had proof. The dust between us and the galactic core blocks visible light almost completely. Looking at the center of the Milky Way with your eyes is like trying to read a book through a wool blanket. So the only way in was radio waves and infrared. Patient, slow, and full of static. That's the world Ballack and Brown stepped into when they aimed Green Bank at Sagittarius. They expected confusion. Instead, they got a dot. The dot was small, suspiciously small. Whatever was producing the signal had to be packed into a region no bigger than our solar system. And yet it was outshining everything around in radio. 8 years later, in 1982, Robert Brown gave it a formal name. He picked the asterisk because, in atomic physics, an asterisk marks an excited state. And this thing was excited. It was screaming. But it was also dark. Across every other wavelength, the spot was nearly invisible. No bright star. No glowing nebula. Just a pinprick of radio noise, sitting exactly where the galaxy's mass seemed to want to pivot around. People started using a careful phrase. A compact, dark, massive object. Astronomy code for, we think it's a black hole, but we can't say it out loud yet. The problem was simple. To prove a black hole, you can't see the black hole. You have to see what's near it. You have to watch something else move, and watch it move in a way that only one kind of object can cause. So, a young astronomer in California started doing exactly that. Her name was Andrea Ghez, and she chose her targets carefully. Here's the thing about a black hole. It isn't a hole. It isn't even particularly large. A black hole is just gravity that won. Imagine you have a marble. Push it harder and harder until it's so dense that even light can't roll back up the hill it's making in space-time. That's it. That's the recipe. The size matters. Sagittarius A star has a mass of about 4.3 million suns, all crushed into a sphere roughly 24 million kilometers across. That sounds enormous, but on a galactic scale, it's microscopic, smaller than the orbit of Mercury. If you swapped our sun for it tomorrow, Earth wouldn't get sucked in. We just go very, very dark and very, very cold. Gravity at our distance is gravity at our distance. The boundary around a black hole is called the event horizon. It's not a wall. It's a one-way door. Cross it, and not even a photon traveling at 300,000 kilometers per second has enough fuel to climb back out. Anything that falls in is, from our universe's point of view, gone. Not destroyed, just deleted from the rest of existence. And our galaxy spins around one. But here's where it gets strange. For 30 years, starting in the early 1990s, two teams, one led by Andrea Ghez at UCLA, the other by Reinhard Genzel in Germany, pointed the world's biggest telescopes at the galactic center and did something nobody else was doing. They watched individual stars, year after year. They tracked them like satellites, and the stars were moving. Fast, insanely fast. One star, called S2, comes whipping around the galactic center every 16 years. At its closest pass, it's traveling at 7,650 kilometers per second. That's almost 3% the speed of light. For comparison, Earth moves around the sun at 30 kilometers per second. S2 is going 250 times faster, and it's circling something we cannot see. When you plot S2's orbit, it draws a perfect ellipse. And at the focus of that ellipse, where the math says the mass must live, there is nothing. No star, no glow, just a point. Genzel and Gez calculated the mass of that invisible point. The number came out the same every time. For a million suns, compressed into a region the size of our solar system. There's only one thing it can be. For their work, Andrea Ghez and Reinhard Genzel shared the 2020 Nobel Prize in Physics. But the smoking gun came 2 years later. On May 12, 2022, an international team called the Event Horizon Telescope held a press conference and showed the world the first direct image of Sagittarius A star. The picture is a fuzzy orange donut, a bright, tilted ring of glowing gas wrapped around a dark center. The dark center is the shadow of the event horizon. It is the silhouette of nothing, light bending around a place where light can't escape. Capturing it took 8 separate radio telescopes spread across 4 continents, from Hawaii to Spain to the South Pole, all linked into one virtual telescope the size of Earth. The technique is called Very Long Baseline Interferometry. The observation ran for 10 days in April 2017. It then took 5 years and roughly 5 petabytes of data, about 1,000 laptops worth, to process the image. The dot Ballack and Brown found in 1974 finally had a face. And the face was exactly the size Einstein's equations had predicted more than a century earlier. And just when you think we've figured it out, Sagittarius A star throws us a curveball. It's quiet, embarrassingly quiet. Most supermassive black holes at the centers of other galaxies are loud, violent things. They tear apart gas clouds, fire jets across thousands of light years, and outshine every star in their galaxy combined. They're called quasars, and they can be seen from the edge of the observable universe. Ours doesn't do that. Sagittarius A star is consuming material at less than 1/10,000,000th of its theoretical maximum. It barely eats. Astronomers describe it as dormant, but that's polite. It's starving. Why? Nobody is fully sure. The current best guess is that some violent event in the past, maybe an explosion, maybe a galactic merger, blew most of the gas away from the central region. Whatever's left is too thin and too hot to fall efficiently. Material drifts toward the event horizon, then gets blasted back out before it crosses. But every now and then, Sagittarius A star wakes up. NASA's Chandra X-ray Observatory has caught it flaring up to 100 times brighter in just a few hours. We don't know what causes the flares. The galaxy keeps secrets. Right now, as you watch this, our entire solar system is moving. Not just rotating, not just orbiting the sun. The whole package, sun, Earth, every planet, every comet, is racing around Sagittarius A star at 230 kilometers per second, about 500,000 miles per hour. It takes us 230 million years to make one lap. The last time we were where we are now, dinosaurs hadn't evolved yet. The first proto-mammals were still figuring out warm blood. By the time we complete the next orbit, nobody knows what or who will be here notice. And here's the part that changes how you look up at the night sky. Sagittarius A star is 26,000 light years away. That means the radio signal Ballack and Brown picked up in 1974 left the galactic center while humans were still painting cave walls in Lascaux. The light hitting the Event Horizon Telescope this morning was emitted while the last ice age was ending. When you walk outside on a clear night and look toward Sagittarius, you're looking toward the gravitational anchor of everything you have ever touched. And it is older than agriculture, older than language, older than us. 60 years ago, Carl Jansky listened to a hiss from Sagittarius and called it noise. 50 years ago, 2 men in West Virginia circled a dot on a printout and gave it an asterisk. Today we have its photograph, its mass measured to the digit, and stars whirling around its silhouette like moths around a streetlight we still can't see. But we still don't know what's inside the event horizon. We can't. The laws of physics that we use to describe the universe simply stop working at the singularity. There's a 4 million solar mass piece of our own galaxy where reality, as we understand it, has a hole. And every star you've ever seen, every constellation you've ever traced, every photon that has ever entered your eye, all of it is orbiting that hole, patiently, silently, for another 230 million years. Until the next lap, if this rearranged something in your head, the next video goes deeper into the dark. We're going to talk about what happens to a single atom from the moment it crosses an event horizon, what physics says, what mathematics breaks, and the wild new theory that suggests the information might come back out billions of years later. Subscribe so you don't miss it. Thanks for watching. If this sparked a question, drop it in the comments. It might be our next video. We'll see you next time.